So now let's go ahead and consider the reactions of carbonyls with weak and neutral nucleophiles. So we're going to consider the reactions of water. All of these are neutral, alcohol, and ammonia derivatives. So let's go ahead and consider the first reaction, which is the addition of water. So the first one is the water addition. Now this reaction, we call it hydration. And hydration can happen in both in acidic and basic medium. If you are doing the acidic medium, you have to start with the neutral nucleophile. If you're doing the basic medium, then you're going to start with the OH in there. So we're going to consider both in there. Let's consider this example. All of these reactions, they are reacting with carbonyls of aldehydes and ketones. So the reaction with hydration, this means that you are adding water, okay? And the addition is going to be in acidic medium. The reaction is reversible. And in this reaction, what you're adding is water, which is a hydrogen and an OH. So you're going to add the hydrogen to the oxygen and an OH to the carbon. This is what you're going to add. And your product is going to end up being a geminal diol. So on the carbon of the carbonyl, you're going to end up having two OHs in there. We're going to call this a geminal diol. It's a diol because you have two OHs in there on that carbon. So if you want to go backwards, all what you need to do is lose an OH here and the hydrogen in there. This is two sigma bonds. Every time you lose two sigma bonds, you're going to form a pi bond. So you're going to form a carbonyl and you're going to be back to your carbonyl. The mechanism of the reaction is a straightforward mechanism in acidic medium. So every time you see an acid in your reaction for oxygen nucleophiles, these are neutral nucleophiles in there. This means that the first step is going to be the protonation. Typically, we add the H plus in there to activate the carbonyl in the first step. This is always the case. So every time you have an acidic medium with oxygen and nucleophiles, then the first step is to go ahead and protonate the oxygen of the carbonyl. And this rule, we're going to use it also in the next chapter as well. So the mechanism of the reaction, here you go. You're starting with your aldehyde and you are reacting this with a nucleophile. And we said that weak nucleophiles, you cannot react them directly. So you cannot say, you know what, that this water is going to come and attack the partial positive carbon. No, you cannot do this because the water is a neutral. It's not an OH minus. If it was an OH minus, that is a strong nucleophile. So the reaction simply can happen. But because it is not a strong nucleophile, you need a protonation step first. So step number one in the reaction, your lone pairs on the oxygen are going to act as a base, and they're going to come pick that acidic hydrogen in there. So when they come pick that acidic hydrogen, you are going to end up protonating the oxygen. It's a straightforward reaction in there. Here you go, with a positive charge and a hydrogen. Now, after you protonated the oxygen, now this carbon of the carbonyl is ready to accept the water as a nucleophile. So now it is partial positive and it is way more electrophilic. So now this carbon over here is more electrophilic than this carbon over there because of the positive charge on the electronegative element. So now this carbon of the carbonyl is ready to accept the neutral nucleophile. So we're going to continue over here in the next step of the reaction, and we are going to add the water now. Okay, so let's label the steps though. So this is going to be step 1 is the protonation, and then step 2 is going to be the neutral nucleophile attack. Okay, here the water is going to come, it's going to attack the partial positive carbon and form a lone pair on the oxygen. So as I mentioned, in acidic medium, you don't need a solvent in there. So you're going to end up having your OH. That is going to be your water. Okay. And you have your hydrogen in there. Please don't forget your charges. Your charges are a must in the mechanism of the reaction. So now what you have is a protonated oxygen. So you need any base. This is an acid. So that protonated oxygen here is acidic. And it makes sense because the medium is acidic. So your intermediate has to be an acid. It cannot be a base. So now I need to get rid of this hydrogen over here so that my product is neutral. Always make sure to get a neutral product. So we're going to search for this in the solution for any kind of base that we can use. And over here, we can go ahead and use water again. So we can use water again. Neutral nucleophile. So the neutral nucleophile always have double role in there. Its first role is to serve as a nucleophile after the protonation, and its second role is to serve as a base in order to pick any acidic hydrogen in the solution. So that is going to come, it's going to attack that acidic hydrogen and form a lone pair on the oxygen. So you're going to end up getting the geminal diol again, so that is going to be your OH, and that is going to be your hydrogen. So if I want to go ahead and trace my steps in there, just go backwards, okay? This is the carbon of the carbonyl in there. So what did I add? What I added is, first, I'm going to label them in blue. I added the hydrogen when I first protonated. So I added this hydrogen over here when I first protonated. And then I added the OH when I added the nucleophile. And that is going to be my OH in there. This is the addition of the water in there. So if I want to go backwards, then I would need to take out the hydrogen, take out the OH. So this means that I'm breaking 2 sigma bonds. I'm going to form a pi bond, and I'm going to go back to my carbonyl. Hydration reaction can happen also in basic medium in the same mechanisms that we've talked about before. So the hydration can also happen in basic medium. So now if it is in basic medium, I shouldn't have any acid in the solution. If I consider, let's say, for example, something like this, and I am reacting this with basic medium hydration. So hydration means I am simply adding water. If I am doing a basic medium, then it's going to be in form of an OH. So you would need a base in the solution. So hydration is always water. This is hydration, acidic medium. This is hydration, basic medium. The products are going to be the same, but the mechanism is going to be different because now what I have is my nucleophile in there, and that one is a strong nucleophile. So it doesn't need anything. That strong nucleophile is strong enough to attack that partial positive hydrogen in there. So it's going to come and attack in the usual a nucleophile, strong nucleophile mechanism that we've talked about earlier, form a negative charge on the oxygen. You have your OH in here, okay? And then the next step is the solvent. So basic medium requires a solvent at the end. So for the solvent, I am using water, and that water is going to come and protonate the oxygen as usual, and I'm going to end up getting again a geminal diol. So this one is going to be again a gem diol. The second reaction, we're going to consider alcohol as a nucleophile in acidic medium. So reaction number 2, we're going to do alcohol addition to the carbonyl. And in this type of reaction, normally we use 2 moles of the alcohol, unless stated otherwise. Unless I ask you, go ahead and use just 1 mole. Let's have an example. Cyclohexanone. I am reacting it with an alcohol in presence of an acid. So let's start with the first mole of the alcohol. So adding the first mole of the alcohol, the first step is going to be the protonation. Remember what I said, if you're using a neutral oxygen in nucleophile, then your first step is always going to be the protonation of the oxygen of the carbonyl in there. So I am adding a hydrogen to the oxygen, and I am adding an OR from the alcohol to the carbonyl. So my product for the first step of the reaction is going to be an oxygen, a hydrogen, and an OR. So let's label them. The OR comes from the alcohol, and the hydrogen is going to come from the acid. This here, we're going to call it a hemiacetal. A hemiacetal is a compound that has an OH and an OR on the same carbon in there. So that is going to be the first step in the reaction. So that is going to be step 1 in the reaction there, where you are going to form the hemiacetal. You can stop at the hemiacetal if you are using just 1 mole of the alcohol. Now, if you wish to continue, then we're going to go ahead and use another mole of the alcohol. So another mole of the alcohol in there, again in acidic medium. So every time you're throwing an acid in the reaction and an alcohol. So now what you're going to end up having is another OR that is going to add, let's use another color. So another OR that is going to add and replace the OH. So that OR in there from the second alcohol is going to come and replace that OH. Now think about it like this. How it's going to replace the OH in there. It's going to replace the OH because the OH is going to turn into water from the H plus in there. So that oxygen, remember what I said, every time you have an oxygen and you have an acid, then you're going to end up protonating the oxygen. You're not going to protonate this oxygen in here because ROH is a stronger base than water. Water is a weaker base, so water is a better leaving group. So this is why it's better to protonate this oxygen rather than protonating this oxygen. Alcohol. Your product in this case is going to be an acetal. An acetal is a compound that has 2 ORs on the same carbon. And those ORs, they come from the direct addition of 2 moles of the alcohol. So here I am adding the second mole of the alcohol, then I can go directly to my acetal product. Your leaving group is going to be water in this case because water is going to leave. So let's go ahead and draw it out. So this is going to be water as a leaving group. Start with the carbonyl. we're going to react it with the first mole of the alcohol in presence of an acidic medium. So again, rule, the alcohol is a neutral nucleophile. It is oxygen-based nucleophile in there. So this is why you have to start with an acid, and so this is why the reaction, it needs to be driven by the acid in there. And the first step is the protonation of the oxygen by the acid. Show your arrows, please. The lone pairs are going to come. They're going to attack that H plus. Of course, when I say acid, you guys, I mean, for example, like H2SO4. So this here is going to have an HSO4 minus that is going to leave. But normally this one, I don't even mention it in there, but it's found in the solution. So if I need any base in the solution, I can, instead of using the alcohol, I can use the HSO4 minus, which is in the solution, to pick any extra hydrogen and return back into H2SO4. So first step is the protonation of the carbonyl. Here you go. Now, once you protonate the carbonyl in there, it's going to be a plus charge. Now, what you did to this carbon now, it's partial positive. And this carbon now is going to be way more reactive. So this partial positive carbon is going to be now more reactive so that the neutral nucleophile can come and attack. So now the neutral nucleophile can attack. So you're going to go ahead in the second step of the reaction. The neutral nucleophile is going to attack. This is going to be the first mole of the alcohol now. Okay, so the first step is I protonated the oxygen. The second step, I'm going to start using the neutral nucleophile. So now the neutral nucleophile is going to come and attack that partial positive carbon, open the bond, and form a lone pair on the oxygen. I'm going to end up having my OH. My target is to reach the hemiacetal. Okay, this is my target. I want to reach my hemiacetal in there. You know the structure of the hemiacetal. The hemiacetal needs to have an OH and an OR. This is what a hemiacetal is. I have the OH, I need the OR, so I want to get rid of this hydrogen in here. Any base in the solution can do the job. Either an HSO4 minus can do the job, or I can simply use another mole of alcohol that can also do the job. Whatever you want. I'm just going to go ahead and use the HSO4 negative because it is a strong base. And that base is going to come, take the hydrogen, form the lone pair on the oxygen. So now I generated the acid back. I generated the H2SO4 back so that I can use it again. So now I'm going to end up getting my hemiacetal. In these types of reactions, your guide is your hemiacetal. So form the hemiacetal in there before you go ahead and you continue. So if I mention in the given that I'm using just one mole, stop at the hemiacetal and that is going to be your product. However, if I'm using 2 moles of this, then this is going to be an intermediate. Then you would need to continue now. So to continue, do the same steps again. So what are the steps? The steps are the addition of the acid, then the nucleophile. Same thing. Here I'm just gonna go ahead and add the acid again, which is the H plus, because I already generated it in here. It's the H2SO4. This is the H plus. So add it again so that I can get rid of that OH in there. And this is going to be a protonation step now. Here you go. So this is going to protonate. Notice my arrows. My arrows are from the nucleophile always to the electrophile in there. I'm going to form my water. There is no lone pairs in there. Take it out and add a hydrogen with a positive charge in there. Here you go. And don't forget your OR in there. So now I'm going to go ahead and I want to get rid of the water. The water is not going to leave like this on its own. Resonance is going to happen to push the water out. So do resonance here, do resonance from the lone pairs of the OR and push the water out. And you're going to end up getting the double bond now, the oxygen and the R with a lone pair. The oxygen over here lost the lone pair, so it's going to be a positive charge. When oxygen makes 3 bonds in the lone pair, it is a positive charge here. And what you have in the solution, you have your water in there. Okay, so water left, and that is going to be my leaving group. Till now, I didn't add the second mole of the alcohol. All I did is I protonated. I made a good leaving group. I kicked out the leaving group by resonance in there. The idea is that the alcohol, the second mole of the alcohol, because it is neutral in there, it cannot attack before making that partial positive carbon very reactive. And to make it very reactive, that partial positive carbon needs to be connected to an oxygen with a positive charge. It's exactly like we did over here. This is now more reactive than this. So every time with the neutral nucleophiles, you want to make sure to have a very reactive partial positive carbon so that the weak neutral nucleophile can attack easily there. So now once I made that partial positive reactive electrophile, now the alcohol is going to attack. So when it's going to attack in there, it's going to attack this carbon, form a lone pair on the oxygen. Again, this is a lot of steps in there. But the steps you would need to understand in order to write them again. So over here, I'm going to end up forming my OR, and what I added is an oxygen, a hydrogen, and an R in there. Okay, don't just look at the mechanism, please write it down so that you are familiar with all the steps. Now I have an extra hydrogen over here in the solution. So any base can pick that extra hydrogen. Let's go ahead and use the HSO4 again. Okay. And that is going to take that hydrogen, form a lone pair, and my product is going to be an acetal in this case.